Hi guys, today we're looking at Euclidean geometry. So we're looking at our theorems. Let's start with our first theorem. Our first theorem, let's say we're looking at a cycle with A, B, C. So we're looking at our cycle with A, B, C. So the theorem will say, or theorem 1 will say, if these two sides are equal, like if AC is equal to BC, then OC is perpendicular to AB. So that will be our theorem. So that is theorem number 1. So we need to prove that this theorem, that if AC is a size or a distance or a length from here to here, if AC is equal to BC, then OC is perpendicular to AB. So we actually want to prove that this line is perpendicular to that line. So what can we do? The first step to do here, you need to do some construction. Let's say we have to construct AO, and we have to construct AO and OB. So this is our construction, AO and OB. This is AO and this is OB. So after constructing AO and OB, it means we have two angles now, or triangles. So we have a triangle AOC and a triangle. So we have a triangle COB. So we have these two triangles. So we need to prove that if AC is equal to AB, then OC is equal to AB. If AC is equal to BC, then OC is perpendicular to AB. Okay, so what can we do? Basically, we need to prove that these two triangles are equal. So that is our goal first. So what can we do? We can say AO is equal to OB. The reason will be radius. It's ready. Okay, sorry, we need to write it like that. So the reason is our radius, so it's ready. That is our reasoning. So whenever you're proving theorems, or whenever you're working on Euclidean geometry, you need to state your reason. So the reason we're saying that it's radius, we're saying that AO is equal to OB. It's because of a radius. So if you're looking at radius, maybe if you're struggling or you're struggling to understand what is a radius. So if we're looking at a radius, if this is our center or point O, so this is O. So if this is our center, it means if you're looking at a radius, we're looking at the line that joins the center with the circle, or with our cycle, or our circumference. So this is R, this is radius. So this radius is the same for any line. So any line that you join from the center to the circumference or to the circle is R. It's equal, even this one would be R. So any line that is joining from the center to the circle, it will always be R, and it's all the same. That is our reasoning to say AO is equal to OB, because you can see this is AO and then this is our OB. So it's a radius. So the radius will be always the same. So that is the first point. Let's look at the second point. So we will be looking at we can say AC is equal to CB, or BC, it will be the same, CB. And the reasoning for this one will be given, because this one is given on the statement, because we're saying if, so that is given. Okay, let's look at the other one. Now we're looking at OC is equal to OC. So OC is equal to OC because it's a common line. It's common side. Why are we saying OC is equal to OC? If you're looking at this circle here, OC, so like basically I told you that we introduced the angle AOC and ACOB. So we have an angle, or we have a triangle like this. So this is A, this is O, this is C, and we have a triangle like this, where this is B, this is O, this is C. So you see OC, so both triangles, they have OC. So there's OC this side, there's an OC this side. So that's why we're saying it's a common side, right? So what does this mean? This simply means that our triangle AOC is equal to triangle COB. What is the reason? We have three sides that are equal. So this is our reasoning, because we have proved now that these two triangles are equal. So you see, if you're looking at this, you can say we have C1 and C2 here. So basically, because we have proved that the triangle AOC is the same as OCB, so this means our C1 is the same as C2. So these two angles are the same. Hence, we can then conclude that therefore OC is indeed perpendicular to AB. So that is our first theorem, and how you prove it shortly. Meet me on the next video for the second theorem. Thank you so much for watching.